the idea is like when you take it,
Yeah. Ah, okay.
it will automatically redraw for you.
Oh.
Yeah. It's more precise, I would say. Yeah, it's a mix of the two because the urban areas definitely have it. But the more recent regulations are...
Try and connect it to the water and it'll pour in there.
Yeah.
So it's
I want to see.
Go like that, the water will get in there.
where there were no...
I want to see if there is no link between inside and outside, or whether there will be some water synced
all that water
into
hits
this
the
flow.
soil, so it goes straight to the streams. So there's definitely an impact, but I would say it's a mix of the two, because like what I was trying to show there, really the more pervious you have, the bigger impact you have on the streams.
Good afternoon, everyone, and welcome to our CURA speaker series. I am Harvey Miller. I'm a director of the Center for Urban Regional Analysis. And those of you who are fans of CURA know that we do regular outreach and speaking events. We usually have several a semester. And we're going to have another series in the fall focused on air quality and public health. We're also going to bring in a speaker from last spring, Maureen McDonald, who last fall who couldn't make it because of weather. She's going to be speaking about using GIS and digital technology to enhance access to healthcare. And also from our project Songs of the 614, we're bringing in Ted King-Smith, who's taking some of our urban data and making music out of it. And we hope to have him ready to give a demonstration of some of the music he's composed from our data this fall. So those are the events we're lining up for this fall, and I encourage you to sign up for our newsletter, follow us on Twitter, like us on Facebook, and we're now on Instagram thanks to Katie Phillips. That's a remarkable advancement for us. So you can follow us on all those social media. But go to our website, cura.osu.edu, and you will find a sign up where you can enter your email and get our monthly newsletters and hear about all the great things happening in CURA, including today's talk by Josh Garber. Josh Garber is the Assistant Director and Natural Resource GIS Manager at the Franklin Soil and Water Conservation District. He provides technical guidance and support to staff and maintains GIS data layers, and he's involved in a number of GIS projects providing expertise and support. He coordinates GIS-based projects with the various Franklin County agencies and local municipalities, focusing on improving water quality and meeting requirements for the Npdes, which stands for National
Discharging System.
Right.
Go into that.
You'll go into that, okay. Held by Franklin County. Josh is a GIS professional, a GISP. He has his master's certificate in GIS from North Carolina State University, a minor in city regional planning from The Ohio State University, and a BS in landscape architecture from The Ohio State University. And if you haven't seen it already, he's brought the Augmented Reality Sandbox. So after his talk, you can go back there and play God and move mountains and make it rain and have things like that happen. Get a chance to experience what that's like. Appreciate you going to the effort to bring that here. But before you play with that, we're going to hear about what's going on in the Franklin County Soil and Water District in terms of GIS and natural resources. So Josh, thank you for coming.
Thank you very much.
And let's hear from you.
Okay. Well, again, thank you for the invite. Thank you for coming this afternoon. What I'm going to do today is focus on two topics that we spend a lot of time on in the district. And then we're going to go through several projects that we have worked on over the years. I will say up front, as you just heard, there's going to be a lot of acronyms and initialisms. If I say something that you don't know, just raise your hand and I'll try to fill you in as best I can. So the main things we're going to look at today are the topic of stormwater and the stormwater permits, which are also known as Npdes permits. Then I'm going to talk a little bit about household sewage treatment systems. And then later on we will get into an array of projects. So to start with, conservation districts. Where did they come from? How did they evolve? So And throughout the 30s, there were dust storms across the United States, so it was known as the Dust Bowl era. And there were storms all the way from Texas to Washington, D.C. During that time, a man by the name of Npdes was very concerned about what he was seeing. And at the time, they put him in charge of the SES, which was a Soil Erosion Service, which was an interesting fact that I did not know before. That later formed into SCS. This is at the federal level. And then it is now known as Natural Resources Conservation Service. So if any of you deal with NRCS, that was the origin. During that time, he spent a lot of time with President Roosevelt, and they were discussing this issue, and they were trying to figure out how to best address it. The main issue is that a vast majority of the land was owned and privately owned. So the national government couldn't do a whole lot about it. So the approach was to make something local. So they came up with the concept of conservation districts. First one was in North Carolina, and today there's nearly 3,000 districts across the country. In Ohio, all 88 counties have a conservation district, and a lot of them are very small. Our district is the largest. We maintain about 20 people, but a couple of them only have a couple of people on staff, or a few of them only have a couple of people on staff. So we deal with water quality on a lot of different levels. And you guys are familiar with some of the issues that have been front and center in the news for the past 40 years. And it's something that we're all concerned with, and we're all trying to find ways to address. So the districts are defined under ORC. A couple of years ago, we were moved from Ohio Department of Natural Resources to the Ohio Department of Ag. So we're now underneath the Ohio Department of Agriculture. We have a 5-member publicly elected board, and we've been around since 1946. So in our district, we have people broken down into these basic program areas. And I'm going to talk today quite a bit about GIS. It's primarily what we're here for, I believe. But I wanted to bring out the fact that in our district, GIS has really become integral to our operations. So everyone providing assistance to landowners, our education and outreach team, our watershed resource specialists, to one degree or another, nearly everyone uses GIS in our office. So as you saw in the previous slide, I had one of the categories there as Geomatics. And we chose that because in our office, we do have GIS, but we also do a lot of data collection from the field. And so we use the GPS systems. Over the years, we've moved from using, which most of the slides you're going to see today, backpack units, Trimble units, that sort of thing. We've gone toward, moved away from those to another system where we're now collecting data on tablets and using an antenna. We use Esri software in our office, and again, we partner with NRCS, and NRCS, through their agreement with ESRI, are able to provide us all the software we need. So from the servers to the desktop to the extensions, everything we're able to get through them. So the first topic I want to go into a little bit is stormwater. And very basically, stormwater is any precipitation that falls from the sky. Okay? It needs to go somewhere. We like it to infiltrate into the ground, but the issue, especially in the urbanized areas, is it generates a lot of runoff. And this runoff causes issues with pollution, and then the accelerated flows cause a lot of issues with erosion as well. So how to deal with this stormwater runoff is a very big and important topic that is only growing. And so in our office, we deal a lot with, you heard the term Npdes, permits, and these are stormwater discharge permits. So essentially the way that it works is all municipalities in urbanized areas are required to have a permit issued through Ohio EPA, and it allows them to discharge 2 waters of the state. So we in our office work not only with Franklin County, who has their permit, but most of the municipalities around Franklin County. And one basic theme that we're always pushing toward education, we go out to the schools a lot, we have a lot of public events that we go to, is just the concept of sewers and most importantly, storm sewers. So the basic thing that we run into a lot is the fact that most people, not most people, but what we run into a lot is a lot of people don't know, whenever you see these catch basins, curb inlets, that sort of thing, none of that water gets treated. It all goes straight to our streams and rivers. So it's a big point of education for us. The other thing we have around Columbus are some of these sanitary sewer overflows. If you're on the edge of campus down by the old Tangi, you'll see some of the warning signs, and depending on what's happened recently, you may be smelling it. But unfortunately, that still exists. So I'm going to talk about a little bit about later on how Columbus is attempting to deal with that at this point in time. So that little graphic on the top right, only rain down the drain, that's a little catchphrase that a lot of conservation districts use. So one of the data sets that we have, we've been working on for over 20 years now, is something we call the Stream Resource Geodatabase. So this started by digitizing from some bylaw sheets, then it moved to us doing a lot of field work where we actually went out and walked all the streams in Franklin County with GPS units, taking pictures of outfalls, trying to get more accurate locations. And then we've been working with a lot of the municipalities around Franklin County to try to get their data sets and combine them. So one, I think, somewhat amazing stat to me is in Franklin County alone, we have over 8,000 miles of drainage. So that's a lot to manage and take care of. Now, one thing with the Stream Resource Geodatabase, so we pulled out here what we call our continuous flow path. So this is surface drainage, all of the subsurface has been removed. And this is a very useful tool for a lot of people because with the GIS you can have directionality on lines. So even if you don't know how to read maps very well, you can very easily tell where the water is flowing from and to. So just very briefly, for those of you who may not be very familiar with GIS, what is it? It's a computer-based technology where you work with data that has geographic location. Now this data can be really anything, and what it has in the background are data tables, so you can do a lot of querying with that data and symbology with the data. So with GIS, the three main geometries you see are points, lines, and polygons. So when you guys look at maps, which is, everyone's looking at maps, if they are from a GIS, you need to remember that there are data tables in the background. So when you see an image like this, which is something that we put together for the city of Columbus, one of their projects, where we're looking at types of impervious layers, impervious cover, as well as utilities, and then the green on top that you're seeing is canopy cover. But when you see a complex map like this, and again, this is only points, lines, and polygons. Actually, this is probably just points and polygons. What you need to know is there's a bunch of information in the background. So every layer that you have in GIS have data tables that go along with them. And some of our tables are very, very extensive. Actually, so Npdes permits. So this is getting into what we deal a lot with. There's 6 minimum measures in those permits that include education and outreach. That's a big part of what we do, as well as a lot of mapping. So that's what we're going to get into a little bit. The stormwater permits came initially, they're resulted from the Clean Water Act. It's administered at the national level by Ohio EPA, but locally by, at the national level by EPA, at the local level by Ohio EPA. So there were 2 phases that came out. They did all the large cities first, which dealt with a lot of the big sewage pollution issues. And now they're still having more come out to this day. What did I hear the other day? I'm not going to say that, but I think there's like 3,000 in the state of Ohio. Or 300 in the state of Ohio, my apologies. So this is what I was alluding to, applies to all municipal separate storm sewer systems. So if you ever hear the term MS4, what it's referring to are those storm sewer systems. They're the drainage ways, the conveyances. So it's not only the subsurface, but it's all the road, the ditches, surface drainage as well that those municipalities maintain. So in Franklin County, the way that it's compiled is you have Franklin County as a whole, but we also have 17 townships. So those 17 townships and Franklin County, and we actually pull out Lockbourne, we're all sharing one permit that we have to meet requirements. So the second topic I want to talk about are Hfts, which are household sewage treatment systems. So there's two basic types of systems for those of you that are not familiar with them. The first is considered a discharging system. Now these are very common, but the general idea to keep in mind is that there is some ground absorption that happens with these systems. So whenever the effluent leaves the house, it's treated on site. It never goes off site. The second type of system are called discharging systems. Now these were very popular in the 70s, and the issue is that at this point in time, a lot of these are breaking down. They're not functioning properly anymore. And where we have an issue with these is any effluent that goes into these systems comes out. So if this system is not operating properly, you're going to be having effluent coming out that is not fully treated and is a pollution issue. So this is what I'm referring to right there is not something that just happens here in Franklin County. It's across the state of Ohio, as well as other states. But what I wanted to make you aware of is this is an issue because of the age of these systems where their failure rate continues to increase. And so we work very, very closely with Franklin County Public Health on this, which I'm going to get into in a little bit. But we're really trying to tackle this as a joint effort in Franklin County.
Josh, if you don't mind me asking, are there actually household sewage treatment systems in Franklin County?
Many, over 3,000. Oh, over 3,000 discharging.
Wow.
And I'll show you a graphic later on. It's way, way higher than you would ever expect.
Yeah.
And something else that's interesting, you don't have to go very far from campus and you can find them. So there's blocks of unincorporated areas that still have aerators in them. Yeah. So I'm not really going to go through these numbers for you, but the idea is just that these numbers are they're very significant. So it's a health issue across the state of Ohio. And what you can see in this, what I want to show you is there were 2008 survey results where you had a failure rate of 30%. By 2012, it's 52%. So it's a real issue. So here are some of the health risks. Why are we concerned about it? We're concerned about it because, like I said, the effluent leaves the property. It has to go somewhere. And a lot of times they go into our storm sewer systems, or they go into our roadside ditches. There are many more that empty directly into our streams. And so this is common sense advice, but you just really want to keep your people and pets away from it. Why do they fail? I touched on this already. Every once in a while, I mean, it's not going to happen anymore for the aerators. But why are there failure issues? Sometimes they're sited in soils that they shouldn't have been put in, or you have drainage issues that then flood the systems and they don't work as they should. You have improper design and installation sometimes, but the big one is the age of these systems. And again, these are a few of the areas whenever public health goes out on a yearly basis to inspect these systems that they're looking for. A big one is the motors. People actually unplug the motors to save electricity sometimes. And whenever they know they're going to get inspected, they'll plug them back in. So here's the first graphic. So these are Hfts systems in unincorporated Franklin County. Columbus has a few, but not very many, especially compared to unincorporated Franklin County. But the reason they exist is simply because we can't get sanitary sewers to them. So there have been issues with annexation with the city of Columbus. And people don't want to annex to the city. So they may want the service, but they don't want to get annexed, so they prefer to stay out. It's a little bit hard to see, but you can see how we've got pockets all over that are unincorporated. So the municipalities have grown all around them. Oops, I think it is. No, that's right. So what I wanted to talk about with there is this is one application of GIS that has been very helpful. These attribute tables I was talking about before, one of the fields in here is where those discharge to. And you can see a very large portion of them go to the MS4s. So this is just a graphic showing what we've been doing the past several years. At the state level, ODA, or not ODA, Ohio Department of Health is now requiring local health districts to have inspections and maintenance plans for all types of systems. So before, a couple of years ago, it was only for the aeration systems, the discharging systems. But coming into play, they need to have a plan for how to deal with all of the systems. So what we started to do over the past several years is go out to the municipalities and go lot to lot and document what's there. So we have, these are the two systems I've been talking about, discharging systems. We have a series of features that we collect for those. As far as the non-discharging systems, we have a series of features that we collect for those. And again, we can go in and record a bunch of information for all those system components. Another thing that we do is we document everything with photos. So if you go and click on a point in GIS, you can pull up a photo of what that system component was. That's photo records. So this goes to your question again a little bit. We have nearly 2,700, we'll say, discharging systems. We've got another 20,000 that we need to go look at. So that's going to be the challenge for public health and our office moving forward. Documentation plans for all of those systems. So it's a very, very big task for Franklin County Public Health. Where we were able to get sanitary sewer in Franklin County, we've got about 16,000 coming. But there's not going to be very many more areas in the near future that they can get sewers to. And here's just an enlargement of that. Looking at, again, how pocketed some of these areas are and the difficulty of getting additional sewage treatment to other locations. So something else we do for these Npdes permits is something that we call dry weather screening. No, we don't call it dry weather screening, it's defined as dry weather screening. But what it is simply going out to the MS4 locations where it enters into waters of the state during periods of dry weather. So the thinking is that if you go out after 72 hours, say after a tenth of an inch of rain, there shouldn't be anything running through those pipes or those ditches. If there is, it's an indication that something is wrong. It's not always wrong, but that's the concept of this. So we've gone out again for Franklin County and most municipalities and done mapping for all the MS4s. So the different things that we're collecting, we're looking again, like I said, natural channels as well as pipes. While we're out there, we're looking for some unique features as well as some pollution issues. So the idea with the dry weather screening is to look for problems. And we do find problems. And most of the time in Franklin County, I'm going to have a series of slides showing you them. They're from the discharging home sewage treatment systems. But they do come from other sources as well. And again, you can see here, this is looking down inside of a manhole. You've got different parts of that storm sewer system that are conveying pollutants. Again, this is kind of old school from what we do now, but I like the photo. And again, with GIS, it's a great way to manage data, so you can predefine a bunch of variables and options before you ever go out in the field. So this is an example of what we're doing whenever we go out in the field. We're looking at basic descriptors of what we're finding. We're looking at shapes, sizes, how it's set in the environment. So is it underwater, is it above water, is it under sediment? And then we're looking for a bunch of pollution issues. So whether we goes from odor to floatables to discoloration. And so these are all the categories that we've looked at over the years. Point generics, again, are just special features. The rest of it are all parts of the MS form. So this is the official definition of illicit discharge by the EPA. And it's anything that's flowing through the storm sewer system, out of the storm sewer system that is not entirely composed of stormwater. So if it's not stormwater precipitation, then they're considering it an illicit discharge. So these are the start of a few slides of issues that we find. These are those aerator discharges. So those systems are not functioning properly and you're getting waste dumped into the environment. And again, some of it will go directly into the streams and some of it goes through the storm sewer systems first. These are just some more issues. With the aeration systems, there's this kind of gray fungus. It's known as sewage fungus, which is prevalent. It's a clear indicator that there's a problem. We find other issues locally as well on occasion.
What is that in the lower right corner?
It's an oil slick. Yeah. So it came from an auto body shop. And just some more images of what we find. And again, both directly into the streams, in some cases, across the yard, into the storm sewer system. And just one more slide on that. And so this was very stunning to me when I was out there. During the summer, a lot of our streams dry up. What you're seeing here is water in this stream bed that is nothing more than effluent from these systems. That's the importance of the maintenance. Okay, so GIS for analysis and planning. I'm going to go through several of our projects that we've been working on. But a big thing that I always try to emphasize is communication with GIS. It's a great storyteller. It can convey a lot of information very quickly. Spatial relationships with GIS, for those of you that don't use them, is very, very powerful. So we will refer to these usually as layers whenever we're working in GIS, but you can look at any type of information that you've given a geographic location to, and then what you can also do is look at how those different layers interact with each other. What are their relationships? So one thing that we've been able to do somewhat over the years is, essentially it's like suitability analysis for those of you that know what that is, but it's that process of looking at these different layers, giving values or scores to those different layers, and combining those different layers and seeing what the result is. So this was an early study that we did for public health, again looking at the density of pollution issues that we found, where the aerators are, and housing density. We wanted to see what areas and locations we should probably visit first and look for problems. So you're able to combine that different information and come up with a ranking system to help guide you. So this is something that we used for several years. We're in the process of modifying this right now, so this is going to become obsolete, but it worked for several years. And so this is kind of how it works if you see it visually. So you've got well, I'm sorry. These are those 3 layers combined. And the way that we work through this is we pulled out the highest values of those layers. And then we looked at where they corresponded to unincorporated areas in Franklin County. And then looked in those attribute tables and were able to give a ranking to those, to every location or group of parcels based on those variables. And so then this allowed them to go out and look at some of these areas much more closely than others. So what they actually did for a couple of years was go house to house, look at connections inside the house. Because what happens is a lot of people will have washers and dryers and sinks connected to their system as well. Something we're able to do for the city of Dublin. They were looking to extend sanitary sewer. And they had a big process that they used to do that evaluation. But one component that they learned from us was the impact of these Hfts. So again, we went out with Franklin County Public Health, mapped all the systems that were out there. Both the discharging and the non-discharging systems, and did complete because it's so much growing. So when we're out looking for this, we're looking for impacts to structures as well. But what I was going to say real quickly too, also, because you have these geographic features, you can quickly generate stats on percentages of impacts or lengths of impacts. Again, very useful tool. So I'm going to talk real quickly, for those of you who might not be familiar with it, about what a watershed is and what we're finding in the urban areas. And there'll be a couple more slides after this. But this was Billingsley Ditch up in Dublin. So the black line that you see going around out here is the extent of the watershed. And so a watershed is simply, if you choose an outlet point, all the locations that drain to that point. Okay? So right now, this is the surface extent of that watershed. This area here is predominantly, the blue area, predominantly the area that is not going through storm water lines. The issue with stormwater lines, not the issue, but something you need to be aware of, is the fact that it speeds up water flow. So it can transport water very quickly into the streams. But in the urban areas, what you will find is that you're getting flows from outside of that natural watershed. So when you're doing that, you're impacting the downstream end of that watershed because it's getting more water than what it naturally should. So you end up with, again, some erosion issues. So what we started to do was not only look at the elevation information, which is where, that one, which is what this extent is derived from. So it's all based on elevation. So we were looking at elevation information along with these storm sewer systems. So as you can see in this graphic again, you have these storm sewer systems outside of the natural watershed. So if you delineate this based on topography alone, you get this extent. But what we were looking to do is actually define the true extent, which in this case would bring the watershed further out in this direction. So we took on this process for the city of Columbus, which I guess I'm going to get to in a moment. I'm going to give you another example of this. So this is Glen Echo Ravine. This is downtown for those of you who aren't familiar with it. It's up in Clintonville. And this is, once we did the delineation, looking at the subsurface drainage, this is the delineation we came up with. And again, with that, you can do all types of takeoffs for forest cover and impervious surfaces, anything. This is just kind of an example for you. But the crazy part of it was that if you look in the data sets that were available based on topographic information only, this shaded area in the middle was the area that was defined for that watershed. So in reality, this area down here, which people were concerned about for many, many years, was getting just overrun by all this additional development that hit that ravine. And so essentially we're calling this a pinch point, but all of this drainage outlets right here. And so what you get are conditions like this. So it's considered a very flashy stream. When it rains, the water drains down very quickly and floods out that ravine. So undertaking this exercise was important because we learned, okay, it's a much bigger area than what people were aware of. And most importantly, most of the work people were doing were down here. But these are where, you know, you have your problems, but it's not the source of the problem. The source of the problem is upstream. So we were able to work with some of the local watershed groups, and they started doing more infiltration practices and that sort of thing up in the watershed to alleviate the issues that you see down here. So these flooding pictures that I just showed you are in this location down here. So the city of Columbus, they're dealing with this as well. For those of you who haven't heard of the Blueprint Columbus project, because of the sanitary sewer overflows that I mentioned at the beginning, they put together a proposal for Ohio EPA and a plan to deal with that. So, down to the bottom, these are the techniques that they're using to try to eliminate those sanitary sewer overflows. So this lateral lining is important because you have infiltration issues in those systems. So they're trying to keep the water from seeping into those pipes, which then overload the system with extra water and cause those discharges. So these they're doing to help just again control where the water goes. This is where we came in. So they wanted us to kind of do two passes, or a couple levels of this. The first one was they were doing some planning work. So we went out and we did delineations across Franklin County. The areas that are showing up without any color in them, they're draining, directly to the river, the south, so there's no real outlet point. Downtown is a whole combined sewer system area. So that's been looked at now, but there's more work to be done there because it's a very, very complex system. Again, using GIS is just a great way to do, so we did takeoffs of all these, and what we're looking at here is representing impervious cover percentages. So if you don't have much impervious coverage, and when I'm saying impervious, it's like roads, roofs, sidewalks, driveways, that sort of thing, anything that doesn't let the water seep in. The more that you have, the less supporting it is of the natural drainage ways. So you're able to represent that across Franklin County. So again, the green areas are good supporting, the orange, they're not supporting. Undertaking this, for those of you who use GIS, this would have been probably a very undoable project, or it would have taken an incredible amount of time if it was done manually. But I would encourage you to look into models. It has been a lifesaver for us, and you'll see another graphic here in a minute that helps support this as well. It allows, for those of you who don't know, the models allow you to automate a series of processes. And again, doing that manually would just take an incredible amount of time. So what we ended up doing then for them later on, all these blue little dots are catch basins. And so they were doing these rain gardens, these infiltration gardens, different places. They needed to know how much area was draining to those. So they actually had us go through and do delineations for every single catch basin. And again, this was looking at the subsurface structure, so we know exactly how much area is drained to each location. They've got these projects planned out for more than 30 years. They just got an extension on it, so I'm not exactly sure what that's going to do with the time frame. And again, just one more example of looking at a watershed and several variables to help the city of Westerville decide where they should try to implement projects. So the Center for Watershed Protection is a group that we get a lot of our information from, and they had some formulas that you could use looking at these variables of impervious, canopy, turf, and soils, and figuring out what the general impact is on these watersheds, or these sub-watersheds to the stream. On this slide, I just want to bring out the point that with these data tables, again, you can start to create targets. So if you know that you have to hit a certain percentage of impervious cover, and you know you're over it, you know how much then you need to disconnect. And when I say disconnect, it's allowing it to go into an infiltration practice rather than going directly to tube streams. This was something we worked on with a consultant to get a canopy cover for Franklin County. So they were able to get the expense from us, or for us, and then from that I was able to go in with LiDAR. For those of you who aren't familiar with LiDAR, they have technologies where they'll fly planes, shoot down lasers, and you get very accurate elevation information. And so when you apply that elevation information, you can quickly see the relative, not the relative, the actual height of canopy trees. So you can see with the darker blue where these older stands of trees are. And this has been a favorite layer for metro parks. So we did a study looking for vernal pool and wetland locations, much smaller locations than existing data sets. And so I'm just going to tab through these, but you can see these different layers. So we're looking at something called sinks. And so you can look at this elevation information and find areas where the water doesn't drain out. So it's considered a sink. So the water drains, it can't drain out. So we're looking at sinks. We're looking at soil and their properties. We're looking at slope. And then we wanted to incorporate this canopy layer as well because a lot of the vernal pools are in forested areas. So when you combine them, you get this range of values again. And in this case, the dark blues are the higher values, the whites are the lowest values. But what you can do then is again extract out just the highest values, which leave these little pockets. We did have several false positives. But it helps tremendously because if you look at this image here, it's an area, it's a forested area. It's really hard to tell that there would be a wetland there, but this was actually one we went out to verify. And in fact, there was a wetland in that location. And so I've clicked through a lot of these things. I'm not quite done yet. I have a few more things to cover. But in our world, we deal with natural boundaries a lot. When you're using GIS, if you're looking to summarize data, you need to consider kind of what your purpose is, what you have access to. But you can summarize data in a lot of different ways. One more thing I wanted to bring out for you guys who may be interested in collecting data. There's a system run by the state that have monuments set across the state that help to triangulate the GPS signals and correct them for higher accuracy. And they have a system, it's the VRS RTK network, where with the process we're using right now, we have antennas that will do this correction for you automatically. So we have very high accurate location information from the field. So if you're not familiar with this and you're doing data collection, I just wanted to bring it to your attention. So at this point, I covered a lot of ground, a lot of terminology, and would just like to know if there's any questions. Okay, go ahead.
I noticed that when you were talking about the data sets that were available in GIS, that one layer was demographics. What kind of demographic information is there and where does it come from?
You can get demographic information from Esri if you have an account with them. You may be able to check with Morpsey. They would be a good source for it too, I believe.
Whenever you see a sewage water failure in the field, are you then reporting it somewhere, or are you able to take a sample or something?
So for the sewage, yes, for the sewage, Franklin County Public Health deals with those issues, so we always report directly to them. So if we find an issue out in the field, we come back, record it, contact Public Health, and they'll go out and do the investigation and work on fixing the problem. Okay. So, as was mentioned at the beginning, We do have an augmented reality sandbox in the back for you. This was developed in our office by someone, I don't remember who exactly was Katie, as a means to get out to the public, and especially for the schools, to help educate children on topography, watershed, how water flows, and it's something that you can construct on your own. The software was developed at UC Davis, so it's free to use. There is some hardware back there that you need to purchase. So for us, it was about $5,000 investment, which does include some outreach material. But it's a joint effort between our office and the Franklin County engineers. So both of us have been putting it to use. And yes, as I was saying, so we go out to the schools in Franklin County and have been using this. So that, I believe, is all. Here's a group that does all the GIS data. We have a couple guys that spend more time in the field, a couple guys that are in-house. We have an in-house server at this point in time, so one guy is pretty much dedicated to that and kind of quality control. And then the other folks are in and out of the office as needed. So, anything else? Any questions? Sandbox. Is it up and running? Yeah. Okay. Do you want to say that?
So one of the big threats we're facing here in Columbus with climate change is going to be extreme storms and flooding. So tell us, not to worry, tell us what you're doing about this.
I can't tell you not to worry, but there are going to have to be changes made, and Ohio EPA, was it last year? It was either last year or the year before, actually changed their general construction permit requirements. So anytime there's development, you have to have a means of controlling the stormwater. So a lot of times that's been just on-site retention. There's a lot of practices going underground now, so we're doing a lot more infiltration underground. But they changed the requirements to increase those volumes because it is real. And the number of calls that we get over the last year about people having flooding problems when they've never had them before. We've never had rain like we did last year. I mean, it's another record year. So it's, I've seen other presentations from folks here at OSU on the topic, and it's pretty undisputable. So we just have to make adjustments. So but a lot of it has to do with that, managing that stormwater. So you don't want it getting into the streams fast. You have to have some way to control that. The Blueprint project, that's again what that's all about. So they're putting all these rain gardens and all these pervious pavers, different locations to try to get that water in the ground and stop that hard rush to the streams.
And what's been the acceptance by the public so far of green infrastructure with the rain boxes? Is that a positive, negative mix?
There's been a mix. So the Clintonville area, what I was told was that Columbus did not do a good job of relaying what they were doing. And so for a while, I mean, it made it in the papers, people were upset. We had people leaving us mean messages, even though we didn't have anything to do with it. So I think there was a communication issue with that. And then we're going to have to see. So they're trying to make some adjustments for it. So some people like it. I mean, by and large, people like it. But whenever you impact people's front lawns and their parking areas and their drive areas, it's a different story. So I can't tell you all the specifics as to what they're doing to try to mitigate that, but yes, they ran into a little bit of a problem with that. But there's green infrastructure. Like if you go to Morpsey's website, we had developed a green infrastructure, what we call a green infrastructure tour, but essentially it's a compilation of locations around Franklin County where there is green infrastructure. They took that over. So if you look on Morpsey's site and look for green infrastructure, they have several locations, and with a conversation with them yesterday, they're going to be putting a lot more effort toward that probably in the next year or so to try to get more examples of projects. Not big, not just, like have you been to Griggs by chance? Griggs Reservoir? So you know all the big detention basins they put out there?
I haven't seen that.
So some of these practices are not small, like these little rain gardens. They're very large areas that they're trying to take in this volume of water.
So, fun fact, our office is right beside a park. It's called Wyman Park. And 5 years ago when we moved in there, they were putting in those big, what are they? They're like...
Yeah, so they're chambers.
Yeah, water chambers to help slow down that stormwater.
Yep.
And it worked, but that's been so extreme with the rain lately that our office still floods.
Yeah.
Any other questions? Well, maybe you can give us, to finish up, we can, relax the session formally and have you go over and take a look and show people how this works.
Yeah. The idea is like when you take it,
Yeah. Ah, okay.
it will automatically redraw for you. Yeah. It's more pre-selection, I would say. Yeah, it's a mix of the two because the urban areas definitely have an impact. But the more recent regulations are.
Try and connect it to the water and it'll pour in there.
Yeah.
So it's
I want to see.
Go like that, and the water will get in there.
where there were no.
I want to see if there is no link between inside and outside or whether there will be some water synced
So all that water
into
hits
this
the
scope.
services and goes straight to the stream. So there's definitely an impact, but obviously it's a mix of the two because like what I was trying to show there, really the more pervious you have, the bigger impact you have on the stream.